Types of faults: normal, reverse, thrust, and strike-slip faults explained. The Earth never sleeps. Beneath our feet, immense forces are constantly reshaping the planet, fracturing the crust and giving rise to breathtaking landscapes and devastating quakes. Understanding the main types of geological faults is essential for grasping how our planet moves, breaks, and rebuilds. Faults are fractures in the Earth's crust where blocks of rock have slipped past one another. These movements are not random, they occur under predictable forces and align with three main categories: normal, reverse, or thrust, and strike-slip faults. Recognizing these types helps us decode the tectonic story of any region on Earth. Normal faults occur where the crust is being pulled apart by tensional forces. One block of rock slides downward relative to the other, creating valleys, rifts, and fault-block mountains. They are commonly found at divergent plate boundaries, such as mid-ocean ridges or continental rift zones like the East African Rift. In contrast, reverse faults, including their steeper cousins known as thrust faults, form under compressional stress. Here, one block is pushed upward over the other, shortening and thickening the crust. These faults are frequent at convergent plate boundaries and are responsible for the uplift of mountain ranges such as the Himalayas or the Andes. Strike-slip faults tell a different story. Instead of vertical motion, they exhibit horizontal movement. The blocks slide past each other laterally due to shear stress. The most well-known example is California's San Andreas Fault, which has generated some of the most powerful and studied earthquakes in history. These faults mark the boundary between tectonic plates moving sideways relative to each other. Each fault type reflects a unique stress regime and tectonic setting, offering clues about the forces shaping that region. Understanding their behavior is vital not just for geologists, but for architects, urban planners, emergency responders, and anyone living in tectonically active zones. To assess fault activity and predict seismic hazards, experts combine satellite data, field mapping, and seismic monitoring. This knowledge helps improve building codes and disaster preparedness strategies. But it all starts with identifying the type of fault and the stress behind it. So next time you hear of a tremor or see dramatic cliffs splitting the Earth, ask yourself, what kind of fault lies beneath?